In this lesson we will see how to perform a KNN with R and evaluate its performances. We first provide a quick recap of what already told on the topic looking at the example in the slide. The dataset is made of 9 observations, 5 are labeled as crosses and 4 circles. Moreover, for each observation we have some features available, which are represented as the coordinates of each point in the slide. The problem we address is the following. A new observation arrives that is the red star and we know its features, so we know where it is located. Using this information only, we aim to predict if its label is a cross or a circle. The idea is that the predicted label for the red star would be the most frequent label among those of the k closest points. More precisely, we specify in advance an integer number k, then we find the k closest points in terms of Euclidean distance. Other distance metrics can be employed as well, but we want to keep it as simple as possible for the moment. Finally, among such k points we find the most frequent label and assign it to the red star. We choose k equals 3 in the example. The 3 closest points are 1 cross and 2 circles, hence the predicted label is a circle. Usually k is chosen to be an odd number to avoid ties. Before introducing the ML tool we will use, let's provide a more concrete example. This exercise is a study conducted over 699 women having breast cancer. The label we aim to predict is whether the cancer is benign or malignant. The reference variable storing such information is named class, which takes 2 values, 2 that stands for benign and 4 for malignant cancer. For each woman, some clinical related variables have been recorded, and you can see their names in the slide. These will be our predictors. The dataset is contained in the file breast cancer txt and can be loaded using the read table function. After that, we split the data in training and test set. Similarly to what we did in previous lessons, we set the first 600 observations in the training set using the squared bracket operator and selecting rows from 1 up to 600 as shown. The first columns store the clinical variable. Having 5 variables, we select columns from 1 to 5. The labels are instead stored in the 6th column, and we save them in a separate vector named y. The remaining observations and the corresponding true labels are saved in the test set. X-test contains the features and Y-test the labels. The R package we need to fit a KNN is called class. This can be installed and loaded as we saw in previous lessons, first using the install package function to download and install the package in library, class, to load its function in the current R environment. We use the KNN function, which requires 4 input parameters that we set train equals x, which is the matrix with the features in the training set, and test equals test, which is the matrix with the features of observations in the test set. The third argument, CL, requires the vector of true labels in the training set, and must explicitly tell R that the input variable is categorical. This can simply be done using the asFactor function on the vector y. The last input is the number points to include in each neighborhood. The output of the model is a vector of predicted labels that we collect in the variable yPredict. And now it is your turn. Repeat what reported in the previous slides. Data are taken from a medical study that aims to assess the conditions for favorable outcome when reaching the hospital after a stroke. The label of interest is named outcome. This has 2 possible values, 1 stands for death and 2 for survived. 600 observations were collected, each with 2 features. Sat, the oxygen saturation in the blood, and time 2m, the time in minutes needed to reach the facility. Data can be loaded as in the slide, and split in a training set made of 500 observations and a test set with the remaining 100 observations.